Hey guys, this is probably the first time you see my face in one of my videos, but now that I've got better recording equipment for doing face cam, I'll be doing face cam a lot. So, there we go. Alright, so today we are going to be talking about covalent bonds. So basically, what they are, covalent bonds are bonds. Well, that's a great explanation of covalent bonds. Oops. Didn't mean to do that. Anyways, so covalent bonds are bonds between nonmetals and nonmetals. A nonmetal and a nonmetal, basically. So their electrons are shared. You don't know what that means yet, and it probably won't make sense to you until probably 5 minutes later. But yeah, so they form molecules. And we can forget about this one for now. I'll be going into that maybe 10 minutes later, probably later in this video. I don't know how long this video is going to be. Anyways, now I have to get my pen again. Okay, so like I said, covalent bonds is a type of bond. And what a bond is two atoms. They connect and bond. That's what the word bond means. So basically they just bond. Now, why do they bond? Why don't atoms just stay isolated, alone? It's because of this thing called the octet rule. So basically in chemistry, there's a rule called the octet rule, stating that every atom, in order to be stable and in order to be satisfied, must have 8 valence electrons. We talked about valence last time. It means the electrons on the outermost shell. And the way to look at how many valence electrons there are for an atom, we just look at the columns on a periodic table. And we will forget about the B group, so we're only going to be looking at the A groups. So basically, group 1A, the alkali metals, the group where hydrogen, lithium, and sodium, etc. are in. This group is group 1A. The group beryllium, magnesium, calcium, etc. are in is group 2A. Then we skip all the transition metals, go all the way to boron, aluminum, 3A, carbon, silicon, germanium, etc. 4A, and then we go 5, 6, 7, 8. Up to the point we reach the noble gases. So group 1A has 1 valence electron. Group 2A has 2. 3A has 3. And I forgot to mention this, but basically the octet rule have an exception, and that exception is hydrogen and helium. Basically, hydrogen originally only have 1 valence electron. Actually, it only has 1 electron, so yeah. Basically, it would only have to get to 2 electrons, and so do helium. They don't have to go all the way up to 8. And atoms have another option, is to lose their outer shell completely. But of course, they still have to have electrons. That's why hydrogen don't just lose this one. Anyways, hydrogen and helium only has to have 2 valence electrons. That's all they need to be satisfied. Okay, so now you might already have an idea of why these atoms bond. They need more electrons. Some of them, as you might see, for example, oxygen with 6 valence electrons, 3, 4, 5, 6, want to get 2 more. Other things like lithium with 1 electron want to lose it completely. So some want to lose, some wants to gain. That's why they bond. Forget about this one. I don't know. It's like my pen slipped. They would want to bond. Oh, actually, that one is for this side. Yeah. I'm stupid. Anyways, they want to bond. But that's ionic bonds. So basically what happens is, it might be a spoiler for the next video, but the basics, it's just, actually lithium won't bond with oxygen. Lithium will bond with, for example, fluorine, chlorine. It just gives this electron. But we'll get more into that in the next video. So in this video, we're going to be talking about nonmetals and nonmetals. The way nonmetals and nonmetals want to why did I say exchange? there will actually be no point in exchanging electrons. The reason, the method how to get electrons, because when we actually look at this, nonmetals always want to get electrons. So they would want to always get electrons, but now they can't. For example, one can't give the other one electron. So how can two atoms of one electron both get electrons? They do it in a very special way. They share electrons. This is what electrons shared in the previous slide means. They actually have to share the electron. So basically, share isn't reuse, but we can see share as being as having the electrons reused. So this electron once shared belongs to both atoms, basically. A great example would be NH3. So basically, this is a molecule, and made with 1 nitrogen and 3 hydrogens. Okay, basically if we look at this nitrogen has 5 valence. If I'm not, 5 valence. So make it clearer. There we go. Each hydrogen have 1 valence. So hydrogens. So hydrogen need 2 valence. Each hydrogen atom. And nitrogen. Each nitrogen atom needs 8 valence. So basically, a way to do this is this hydrogen can share 1 electron with this nitrogen. So basically, this nitrogen gets 1 electron and this hydrogen gets 1 electron. Hydrogen stable, and nitrogen still needs 2 electrons. But with 3 hydrogens, basically, the nitrogen is satisfied. So basically what I'm doing here is I'm drawing a common structure called the Lewis dot structure. Basically, it only focuses on the valence electrons. It does not care about the core electrons or the non-valence electrons. And the way we depict bonds, covalent bonds here, is by just drawing a little line. Yep, just drawing that little line. Right. So basically that's how we do it. This is the basics of covalent bonds. They're a pretty cool form between nonmetals, and also an introduction about why atoms actually bond. In the next video, we're going to be talking about ionic and a teeny bit about metallic bonds. Since metallic bonds isn't all that important as far as I know in 6th grade, and you'll probably only get 1 or 2 test questions on that, still it's an interesting thing to know. And the video after that, we're going to go on to how to name these molecules, bonds, and how to write formulas from their names. So I guess that's pretty much it.